A few more examples of solving some really elementary differential equations. This time we have a second order differential. We have y double prime of t, 24 6 e to the 6t minus cos 4t. All right, so now this is a little bit sneakier than the previous, but not too bad. So we're just going to integrate y double prime of t with respect to t. That's going to be equal to the integral of 24 e to the 6t minus cos of 4t dt. Now, when we take the first antiderivative of the second derivative, that's going to become y prime of t. The antiderivative of 24 e to the 6t is going to be 24 over 6 e to the 6t. All right. So remember, we're going backwards from the chain rule. It's an antiderivative. And then finally, same thing here. Antiderivative of cos is sine. So that's going to be minus 1/4 sine of 4t. And because we have to do a few integrations, I'm going to call that plus C1. All right. So if it's a first order differential, you could just call it C, and that usually can get away with it. But I'm just going to call that one C1. All right. Now, clearly, we know that 24 over 6 is 4. So we could just simplify that right away, but just making sure everybody knows where that comes from. Now, we're going to do the same thing. So we're going to integrate y prime at t with respect to t, and integral of 4e to the 6t minus 1/4 sine of 4t plus c1 dt. All right. So when we take the antiderivative of the first derivative this time, right here, that's just going to become y at t. Right? Over here, we get 4 over 6 e to the 6t for the antiderivative. Antiderivative of sine is negative cosine, but we have a negative in front, so that's going to be a positive. And then we have another factor of 4 in the denominator now. So that's going to be 1/16. Okay, or we could just write it as 1/4, 1/4. All right, since we have to simplify anyway. And this is going to be cos of 4t. Antiderivative of c1 is going to be c1t. Since if that was just like a 5, that would be 5t. So I'm just going to call it c1t, and then plus c2. And so the most simplistic we can make this is going to be 2/3 e to the 6t plus 1/16 cos of 4t plus c1t plus c2. All right. And so that is going to be the solution to our second order differential, this guy right here. Okay, so basically we just do what we did in the previous videos, we just do it twice to solve a second order. All right, now we haven't looked at these problems that have an initial value. And so let's go ahead and solve this type where we have an initial value in here. So we're just going to take, again, the antiderivative. All right, so nothing's going to change with the process until we get to the part where we have to solve for the initial value. All right, so that's going to be integral of 2 plus sine of 2t. That should be a parenthesis and then a bracket dt. All right, so we know that this is going to be y at t, so that's easy enough. And that's going to be equal to 2t. Antiderivative of sine is negative cosine. And because we have the 2 inside as the interior angle, we are going to divide by 2, the opposite of the chain rule. This is going to be 1/2 cos of 2t. And again, because it's a constant of integration with a first derivative or first order differential, we're just going to have a plus c. All right. Now, this is what we call the general solution. And in fact, in all of our examples, okay, we have gotten the general solution. All right. But we haven't taken a look at a particular solution. Okay. So here's how we're going to get the particular solution. Right. What we're going to do is we're going to substitute this initial value back in. What this really means is that we're looking at the point 0, 3. So we're looking for the particular curve in this family, because remember, this is a family of solutions for the general solution. Okay, so remember that this is a family, right? but our particular solution is going to be one curve within that family. So to be able to find that, what we're going to do is we're just going to substitute 0 for x, and then 3 for y at t, okay? Or 3 is going to be y. And so this is going to now become 3, okay? So we're just substituting for y at t is equal to 2, and it shouldn't have been x, it should have been t. Sorry about that, because t is the independent variable. So 0 minus 1/2 cos of 2 times 0 plus c, right? Now, we know that 2 times 0 is 0. The cosine of 0, if we look at our unit circle, okay, so we look right here, cosine of 0, this is the point 1, 0. Cosine is the x coordinate, so that's going to be 1. All right, so really it just turns into negative 1/2 times 1. So we get 3 is equal to negative 1/2 plus c. And so we would add 1/2 to both sides. And so that would give us 7/2 is equal to c. So that tells us that that's going to be the particular member of the family that's going to give us the particular solution. And we just substitute 7/2 back in for c. So the particular solution, y at t, is going to be 2t minus 1/2 cos of 2t plus 7/2. All right, so again, this is our particular solution. All right, so all you have to do to be able to find the particular solution is just go through, find the general solution, and then substitute back in for both the independent variable, which is the first, in this case it's going to be t, and then the dependent variable, which in this case is y at t. All right, so in the next video, what we're going to do is we're going to solve a second order differential equation that has initial values, okay? So that way we can get to a particular solution.